All right, welcome back to part two, folks. We're finally getting into the lesson after maybe the longest three-minute review ever. It was more like 15 minutes, but we'll see that we've actually put in all the legwork for today's learning in the 3-minute review. Yesterday, and then for the 3-minute review, we were solving linear inequalities, and now we're able to tackle, or at least we will be able to tackle polynomial inequality. So here's a polynomial inequality. Notice that we can't use our linear techniques because, how do we isolate an x when there are three of them? Or in other polynomial equations, there might be more than that. So how do we do that? Well, we're going to use one of our other techniques. Not the one where we're isolating x, but either a test point solution where we solve the related equation and then look for these intervals of solutions, or we can even try a graph. How would that look when it comes to polynomial equations? Well, we'll see in just a second. So first of all, what do we got here? We've got a polynomial inequality. I'm going to use the test point technique. I'm going to call this method 1, which is the test point technique. And what was the test point technique? Well, we solve the related equation. Solve the related equation. And that's what we've been working on, right? To solve the related equation is, how do we solve this thing? Well, with the right side already equal to 0, it's really easy to see the solutions to the equations. It's already in factored form. We have x equals -3, x equals 5, x equals a half, and be careful with that. You think of this equal to 0, and then the 1 goes on the other side, divided by 2, x equals a half. Well, now what? Well, that means these are our cutoff points. Our cutoff points between solutions and non-solutions, right? And in fact, we also know that these are, I'm going to put them on there, because it's less than or equal to, these are actually solutions as well. So the idea is that if I find a solution in one of these areas, the whole region will be a solution. Now, it's not as easy as the linear, but there's only 2 regions, right? How many regions do we actually have here to test? Well, we've got this region, this 4 regions. So, what this means is we have a test point in here. Any number in here would work, but I don't know, -4 maybe. And we want to see whether this is a solution to this equation. And so I'm going to do this left side, right side. And notice that it's going to, the right side's just 0 here, right? So when I put this into this equation, I got -4 plus 3, 5 minus -4. I'm going to run out of room here. It's getting a little crowded. 2 times -4 times -1. I'm going to move this over here. The whole test point technique is a little bit tedious as far as all the work that you have to do, I suppose. And then what do I got? I got -1 times 9 times -8 minus 1 is -9, which is, what's that? That's 81. So is 81 less than or equal to the right-hand side? Is the left-hand side less than or equal to, less than or equal to? I goofed that up. Change that. Is that less than or equal to the right side? No, it is not. It is more. So the idea of x equals -4 is not a solution. So that region is not a solution. Now, and off we go. We need to keep going. And here, what would be a good test point value? Would be x equals 0. So I'm going to draw a line there, and here's my second test point value. X equals 0 is my favorite, right? Left side and right side. Right side 0. One thing I want to mention here is that when it's in factored form and the right side is equal to 0, I could think of, I don't really care what the answers are, I could think of it in terms of positives and negatives, right? Because if I'm just comparing it to 0, basically I want to know if this is positive, if this thing's positive, it's not going to be a solution. If it's negative, it will be a solution because that is less than 0. So the idea here, well, I don't really care what this is exactly, but I know that this bracket here, this first bracket, is a positive. So I have a positive, and then a positive, and a negative. So altogether, I've got a positive times a negative, and a positive times a negative is a negative. So is the left side less than or equal to the right side? Yeah, because it's going to be a negative. And so I don't actually need to get out my calculator. If you want, you could just think of positives and negatives. That works when one side is equal to 0. And so these are all solutions, and I've got to keep going. Now, you don't have to watch me do test points for all of these. And in fact, once we get a little more used to this, we'll see patterns and we'll see fast ways to do this. But I'm going to pause the video, do my other two test points, and then hopefully convince you that we know what we're talking about, and then we'll move on to the graphical solution. So I'm going to pause. Okay, here you can see my other two test point solutions. And notice what I did here. Since I'm comparing it to 0, I just thought about when I put in 1 in here, is this going to be a positive or a negative? Well, it's going to be a positive. And when x is 1 here, this one's a positive. When x is 1 here, this one's also a positive. So I've got positive times a positive times a positive. Altogether, that becomes a positive. When I compare that to 0, that means the left side is not less than or equal to the right side. So that means the numbers in this region are not solutions. Dandy. And I do the same sort of thing for x equals 6, and I get that these ones out here where x equals 6 are solutions. So putting that all together, then what's the solution to the polynomial inequality? The solution set is, well, how do I describe these numbers? Well, it's negative 3 is less than or equal to x is less than or equal to a half. And also x is got to be greater than or equal to 5. Those are the solutions. And, we could write it in interval notation if we wanted to, but those are the solutions. Notice on to my second technique. The second technique would be to try a graph. All right, well, the graphing technique. Let me get a different color. What would be green? Green is a different color. Graphing. So method 2. Graph. So in this one, we'll see the graphing, the left side here, what we have is, I'm going to copy the original equation again, if you don't mind. This is the original polynomial inequality, not equation, I should say. And then I have it less than or equal to 0. So what I'm going to do is I'm going to graph this side. In green, and then I'm going to compare it in red to y equals 0, right? Well, that's easy. That's just the x-axis. So I want to know, when is the green graph, this graph here, underneath less than the x-axis? Well, this should be pretty slick because we've done all this practice graphing. It shouldn't be very hard for us at all. And in fact, from earlier, I still know what the x-intercepts are. The x-intercepts are, I'm going to make this in black here, negative 3 and 5 and a half. Those are all x-intercepts, right? They're all single roots. They're all slash roots, if you want to call them that. And notice the leading coefficient is going to be negative, because this one factor is goofed up. So that means it starts high and ends low. And so this graph starts high and ends low, starts high, ends low, slash roots, oops, and I'd put the extra point in there for scale if I wanted to. When x is 0, y is 0, y is 3 times 5 times -1. Now, notice I don't really care, do I? It's a nice check, though. Because really, what am I interested in? I'm interested in the x values where this graph, let's see if I can make it green here. Wonder if I can. Sure. There. Where the green graph is underneath the line y equals 0. There's y equals 0, right? This is y equals 0. And so this down here is y is less than 0. So where is this green graph underneath? Well, I can see there it's underneath all this stuff. It's underneath, and all this stuff is underneath. So what x values give me that? Well, where is the shaded graph? These x values in here gives me this shaded in part of the graph, and these x values here gives me this shaded in part of the graph. Again, what's the solution set? -3 is less than or equal to x is less than a half, and x is greater than or equal to 5. Pretty slick, the graphing technique. And we'll see that we can actually use kind of like a combination of the two methods so we can get through these fast. I'm going to pause that. We still got 2 examples left, but I'm going to pause it here and we'll go through the last 2 examples reasonably quickly.